So now let us look at methods of demagnetizing a magnet. So we have a number of methods of demagnetizing a magnet. So one of the method of demagnetizing a magnet is using the hammering method, and two is using the electrical method. Now I want you to take note that these two methods are similar to the methods of magnetizing a magnet, but now the process is different. So let us start with the first one, which is the hammering method. During magnetization, what we used to do is we used to align this magnet like this. You align it with the Earth's magnetic field. Let's say this is the Earth magnetic field, this is the North Pole, and this is the South Pole. So let's say this one is the magnetic material. Let's say it is a steel bar. So what we used to do is we take a hammer. Let's say this one is your hammer, and then you're supposed to hammer this part while this is aligned in the north south direction, which is the Earth's magnetic field. Now during demagnetization, what you just need to do is to align it opposite to the magnetic field of the Earth. In demagnetization, what you should do is you align this magnet like this, east-west direction. Let's say this is the Earth's magnetic field, this is the North Pole, and this is the South Pole. So you're supposed to align your magnetized material like this, so it is perpendicular to the Earth's magnetic field, and then you're supposed to hammer this part here. So what basically you'll be doing here, you'll be demagnetizing this magnet. So this is one of the method of demagnetizing a magnet. Now this next method of demagnetizing a magnet is using the electrical method. So how can you demagnetize a magnet using electrical method? Now for electrical method, remember in magnetization, during magnetization process, what we used to do is to use a DC. So we were using a DC current or voltage. So it's a direct current. Let's say you can use a dry cell batteries to magnetize this material. But for demagnetization, here we will use an alternating current. So for instance, we can have a solenoid like this. So you need to power up this solenoid with a alternating voltage or alternating current, the same thing. So this is, let's say we use 12 volts alternating. So we always represent alternating with this. So this one is AC. So what will happen is you need to align this in the east-west line. So it is kind of similar with this. So this one should be aligned in the east-west direction. Let's say this one is the east-west direction. Now remember, here in the middle we have a steel rod. So this is our steel rod. This is the material that we are trying to demagnetize. So originally right now it is magnetized, so we are trying to demagnetize it. So we need to align it in the east-west direction and then pass alternating current of 12 volts around the solenoid. So what will happen is that the dipoles will get disoriented. That is the best explanation to give to explain how demagnetization occurs. So we always say that the dipoles get disoriented, whereby it changes the direction of these dipoles. They just disorient, they start looking in different directions. I remember we drew representation of magnets in saturation state, a material in magnetized state, and materials in non-magnetized state. So in non-magnetized state, we say that the dipoles always face in a different direction. In saturated state, we say that the dipoles face in, they are parallel to each other and they face a common direction. And in a magnetized state, the dipoles face a common direction, but they are not parallel to each other. So in this case, when you place your solenoid having the magnetized material inside and then you pass alternating current inside and it is in the east-west direction, so what will happen is that the dipoles will get disoriented, hence you'll be demagnetizing this material here inside. These two methods are the methods that can be used to demagnetize material. So you're supposed to take note of the direction you're supposed to use. For during hammering, you're supposed to place your steel bar in east-west direction, and also in electrical method you're supposed to direct your steel bar in the east-west direction so that it does not align with the Earth's magnetic field. And in this process, you'll be disorienting the dipoles, hence demagnetizing the magnet. Now, one thing that you need to know about alternating current is that it keeps on alternating, like the current reverses in direction. So it keeps on reversing many times per second. I think you know about alternating current. Alternating current, let's say for example, this is an electron here. It will keep on shifting direction from one side to another. Because even if you look at the direction of the graph of alternating current is a suicidal, it's like a sine wave, whereby the current keeps on changing direction. So it keeps on changing direction now and then. So if this is an electron at this point, it will keep on shifting direction from this side to this side. We always use a 50 hertz frequency, so it keeps on switching direction 50 times per second. So this reverse back and forth change many times per second is what causes the disorientation of the magnetic dipoles. So the shifting direction of alternating current causes the dipoles to disorient. So that's why during demagnetization we normally use alternating current, and during magnetization we use direct current, because direct current just follows a common path. So a direct current will just follow a common path, it will just flow in a straight line, but alternating current will keep on shifting direction. Now, a common question you might ask is, why do we have to align this solenoid in a east-west direction during demagnetization using alternating current? So the reason why we align it in east and west direction is so that this material, this steel bar inside here, so this is a steel bar, so is for this steel bar not to retain some magnetism due to the Earth's magnetic field. Because remember, if you align it with the Earth's magnetic field, let us say for example you do this experiment and then you align it with the Earth's magnetic field, which is the north and south direction. So what will happen is that some magnetic field will be induced inside this steel bar due to the Earth's magnetic field. So that's why we try to disalign it with the Earth's magnetic field. So it's supposed to be in the east-west direction for it not to retain some magnetism during the process.